Hi everyone, in this video we're going to go through the sample questions from the Maths Methods Written Exam 1. So this isn't a full exam, they're just sample questions that focus mostly on the new content or the new study design. So I've already done the solutions, but I will talk about the questions, in particular those that are newer to the study design. Okay, so let's make a start. Oops, got to remember it's a PDF. I can't scroll that way. Okay, so in question number 1, we're going to sketch a hyperbola. So with this question, or any question that you need to sketch, just take note of the domain. So here's your domain. So x is going to be any value from -3 to -2 and -2 to infinity. So with your hyperbola, usually you would have for x any real value excluding where you have your asymptote. So for this one it is at x equals -2, but we've got this extra condition that we're going to be starting at -3. So including -3, so we do need a closed circle there. So when sketching any graphs, you do need to label any asymptotes with their equations. So a horizontal graph will be y equals because it only goes through your y-axis, and your vertical asymptote will be x equals because it only goes through your x-axis. Now to work out what your asymptotes are, so this is a hyperbola, so we can't have this denominator equal 0, so it's undefined. If it was equal to 0, that's why it's -2. And I'm sorry, I can't use any other color than my red, but because this whole term 1 over x plus 2 cannot equal 0, that means we have an asymptote also at y equals 1. So there's our two asymptotes. So if you're sketching those asymptotes correctly and you've labeled them, you get your 1 out of 3 marks, which is pretty good. Now for your hyperbola, you do want to really take care with the shape of it. So consider your x-intercepts and y-intercepts, which I've calculated over here. I've just noticed that I didn't put the points on. So it did say to put them with any coordinate, so I would actually only get 2 out of 3 marks for this. So my x-intercept is at 0, 1.5, or 3 over 2 if you like. And don't round. So if I wrote that as a decimal, I could write 1.5, but let's say it was 1/3. You leave it as 1/3. You don't write 0.33. All right, and then my x-intercept, which is here at -3, 0. So I should have put that on as well. So that's my bad. So just making sure that you do that, because to me, these types of graphs to sketch are an easy 3 marks. All right, you should know your shape of a hyperbola. You should be able to put your x and y asymptotes in, and also calculate your x-intercept and your y-intercepts. All right, is there anything else I wanted to say about that? I don't think so. Let's move on. Find the values of x for which f of x is less than or equal to 2. So remember, f of x is your y, basically. So we want less than or equal to 2. So if I draw a dotted line, and now if I did this on my actual exam, I would be possibly running the risk that those 3 marks I got will go away. They might think that's another asymptote I put on there. So if you go on to put anything else on a graph, make sure you rub it out, or even if you did it in pen and you can't rub it out, just state ignore this line. Okay, so I'm just putting this line in to show you how to answer this question, basically. If you had a ruler, which you should have a ruler in your exam, you could put a ruler there and just see. So anything below that line is considered as an x value. So we can see that at y equals 2, we go through -1, and you can maybe see that I've rubbed out my graph. I actually went back and sketched that again. So we're starting at -1 for our x values. Sorry, at this point we're starting at equals -1, and we're going, including all these values here, all the way to infinity. So you can see that's what I've put here, -1 to infinity. But we've also got to consider these values down here. So that goes from -3. So remember your x values. If you need to, get your ruler and actually move it across the page. So just that might help you actually think about, all right, where am I starting and where am I ending? So for that second one, we're going from -3 and including -3, because it's, if I go back up here, it was a part of our domain. And it goes to -2, but doesn't reach -2 because we have an asymptote there. Now, what I've written there, I don't think would be considered wrong, but I do think you should write the lower values first and then the upper values. So I've just switched them around because x equals -3 is less than x equals infinity. So that's why I've switched them. All right, and you can see I've done working out there as well. So if you didn't know what x is equal to when y equals 2, I've just done it there. All right, moving on to question 2. So domain and range, I guess if you've got a question that asks for domain and range, it should be a gimme mark for you. So we're looking at f, so just make sure you got the right function. So x squared minus 9, so that's a parabola that's just been shifted down 9, and we want the range. And it is included because that's your turning point basically. Determine the rule for the equation and state the domain of the function f of g. So this is a composite function. So you should have done some composite function questions in your revision so far. Okay, so that just means we substitute in the function g into f. So you can see I've put the square root of x in for x here. And it does say I need to also state the domain. So yeah, not an overly difficult question, but just making sure you get the domain correct to get the full 2 marks. All right, part C, let h be the function h of x equals x squared minus 9. Now, this is the same as f, but this time we've got a restricted domain. So we want to find the maximal domain such that the composite function exists. So g of h this time instead of f of g or h of g, because f and h are the same. So when you get a question like this, you do need to realize that clearly it's not defined. So we need to consider the domain and range of both functions. So just setting up a little table like this is helpful. And we've come across questions in our trial exams that are explain why. Don't just state this, you do have to put that in, but you also have to calculate the range of h and the domain of g and say that the range of h has to be a subset of the domain of g. So once it's been restricted, okay, so the range of h is here, -9 to infinity, and our domain is 0 to infinity. I've just written it that way, and then I've written it this way, so they actually mean the same thing. So with that restricted range, I then have to go on and think about my domain. So you can see I've just done a little bit of working out here. So we want y to equal 0, so I've let it equal 0, so we're just then solving for x. And also consider whether those values are included or not. So they are included, so that's why we're going from -infinity to 3, and -3 and including 3, and then from 3 to infinity. So if you think of your parabola, all right, it's shifted down to -9, and here is -3, and here is 3. So basically we just want this part above the graph. All right, question 3, find the general solution for 2 sine x equals tan x. So understanding tan is equal to sine over cos, which most of you hopefully know. So if you've got a trig equation and you've got sine and tan, or yeah, you probably have tan with sine or with cos. Or if you got sine, sorry, and if you've got sine and cos together, you would need to change it to tan. So just understanding the relationship tan theta equals sine theta over cos theta, which is what we're using here. So what have we got? We've got a half. So x is equal to pi on 3. So again, you need to know your exact values. I would, during reading time, decipher whether there are any questions that require your exact values, and if there are, I would probably do that first. I would try to just brain dump those exact values for that question, do that question, and then it's done, because you don't want to, you know, have brain farts along the way and you've forgotten your exact values. And then if you do forget them at the very beginning, then you know you can come back to it. But I would, yeah, if there were any trick questions on exam 1 where you needed to know the exact value, and I would say there probably will be, you need to, yeah, I would suggest do it straight away. All right, so when you're doing your general solution, you can either remember the general solutions off by heart, or I'm going to show you just how to do it with your unit circle. So you can see I've done my unit circle here. So here's our unit circle. Now we've got positive, so cos is positive in the first and the second quadrant. Now basically, we've got to get our general solution in terms of n, or you could use k, as long as you have this notation. So if you've used n, you've got to say where n is an element of z. So z just means it's an integer, or you can say where n is an integer, or k is an integer. Just make sure you're consistent with whatever letter you use. All right, so because we're in quadrants next to each other, basically we're going, if I just call that 0, we're going 0 plus or minus pi on 3. All right, so to go in the first quadrant, we're adding pi on 3. To go in the fourth quadrant, we're subtracting pi on 3. Then our next solution is 2 pi plus or minus pi on 3. And that's going to continue for all even values. Whoops, I don't know why I underlined that. Maybe I can just quickly undo it. 4 pi plus or minus pi on 3. So basically here we're just going to be multiples of 2. So that's where the 2 comes from. All right, and then we just put in a value of n. So n can be 0. That'll give us our first, well, depending on what our domain is, can be 0. That will then be 1. So that'll give us 2 pi. It can be 2, which will give us 4 pi. It can be 3, which gives us 6 pi, and so on. So, yeah, if you feel like you can't remember your general solution, just remember the unit circle and you'll be able to work it out from there. All right, moving on to question 4. All right, so this was an interesting one because we've done solving simultaneous equations before. And you should know when they have no solutions, one solution, or infinite solutions. So there's 2 methods you can use. I like to use the coefficients method, so just the ratio of coefficients. So you can see here your coefficient of x for your first equation is a plus 3, so over 2. So that I've written that here. And then your coefficients of y, 9 and a, so 9 over a. Now, if they were the same, then you're going to have no unique solution, all right? So if they were different, you would have different lines. When I say different lines, you have different linear equations. Now, some people like to rearrange them in the form y equals mx plus c, and then you're just looking at the gradient. So if your gradient's the same, they're either parallel or perpendicular, and then when your y-intercept is different, they're going to be perpendicular. When they're the same, they're going to be, why did I say perpendicular? Oh my gosh, let's rewind. Okay, so when your value of m, your gradient is the same, they're either going to be parallel or the same line. Oh my gosh, I can't believe I said perpendicular. And then for C, your y-intercept, if they were the same, then obviously you've got the same line. If they were different, then they're parallel lines. So you can rearrange it like that if you like. Now with this question we do get, and I think this was worth, is this worth 4 marks? Oh my gosh. Okay, I can kind of see why it would be 4 marks, but it's a bit harsh, I think, allocating so many marks. All right, so we've got the a equals -6 and a equals 3. Now when a equals -6 and a equals 3, that means our gradients are the same. All right, so we don't know yet whether they're parallel lines or whether it's the same line. But I know when a equals -6 and a equals 3, our lines do not cross. So if I wanted them to cross, they could be any real value excluding, sorry, what am I doing? Any real value excluding -6 and 3 for them to touch. Now, if they were equal to -6 or 3, so a is equal to -6 or a is equal to 3. Sorry, I should probably write that. You're either going to have parallel lines or you're going to have the same line. So I'm just drawing over the top. We don't know yet. Now, usually we would then do the constants. So 3b over 5. But because a is not a part of that, there's no way to get a value of b, basically. So what we need to do is, you can see, I've just then gone ahead and rearranged the equations into the form y equals mx plus c, which we've got here and here. Now, I could have used this method also. So you can see your coefficient of x is -2 on a, and this. So if those two were equal, all right, we would have the same gradient. So you can do it y equals mx plus c as well. So basically, now that I've rearranged it, I don't want my constants to be the same, so which I've written here. So b over 3 cannot equal 5 over a. So I think if you got to this point, you've probably got 2 marks, maybe 3. Yeah, I would probably say 3. And then you've got a test. So when a equals -6, b can't equal -5 on 2. When a equals 3, b can't equal 5. So we've got 2 solutions. Actually, I would say this would give you 3 marks. This will probably give you the 2. Or maybe a little bit above that would give you 2. But yeah, so this is a tricky question. So putting it in the form y equals mx plus c was required, whereas if above these constants had an a in it, then yeah, that would make it a little bit easier. All right, moving on to question 5. All right, so it's nice that they put this question in, because students always get average rate of change and average value mixed up. They see the word average and think they're interchangeable. They are not. So on recent past exams, they have put them together, I guess, to say to students, hey guys, they're different. They're 2 different things. So average rate of change, you are just finding the gradient. So here is, well, here's part of the formula. So it's just y2 minus y1 over x2 minus x1. All right, just rise over run gives you your average rate of change. So we're going from x equals -1 to 1. So you can see I've substituted that all in to get 0. Now, don't worry if you do get an answer of 0, because you're like, oh, how can I have an average rate of change of 0? If we were to sketch that, it would make sense. So you can easily do a quick sketch, but yeah, you can have answers that might look like, you know, you might want them to be a little bit different, but doesn't mean you're wrong. All right, and then with average value, so average value of a function is not on your formula sheet, but it is very easy to remember. It is just 1 over b minus a, and then you've got your definite integral. All right, so 1 over b minus a, your higher number minus your lower number, and that's easy. Yeah, so you can see I've then gone ahead and done the definite integral. All right, question C. So I didn't use the formula on the formula sheet because I know that the area of a trapezium is a half a plus b times h. You can use the formula from the formula sheet, and I think there was a question, yeah, so I'm actually looking at it now, on the second exam where they've actually substituted values into the formula from the formula sheet. So they're basically, instead of having this h on the end, they've just put it as a constant, common factor out the front. So that's the main thing. And because the width is, except for this question, but other questions, your width, which is your height, this distance here, in this case it's 0.5, but often it's just 1. So the number out the front is often a half, but in this question it's not, okay, because your height is not 1, it's 0.5. All right, so let's go through this question. We're finding the total area of the 4 trapeziums. Now, it is a parabola. So I know a parabola is symmetrical. So I've got my two areas here, A1 and A2, and I know that A1 is the same as that and A2 is the same as that. So effectively, I only need to calculate the area of 2 trapeziums and then just make sure I multiply it by 2. So you can see I've done that here, multiplied it by 2. You can go ahead and do all 4, but just looking for symmetry just saves you so much time. All right, and you'll find that every now and again, especially with area questions, or it could be a triangle. If you, say, had to find, sorry, I'm just going off track here, like if it was a linear graph and you had to find this area, that is the same as a triangle, so half base times height. You can definitely use that if you wanted to. All right, so I calculated area 1 here, so hopefully you know how to do the area of a trapezium. So f of 0 is just this height, which is basically the a in our formula, and then the next point is here, which is the b in our formula. Just noticing here that your distance is 0.5. That's why I've multiplied by half at the end. Bit of fraction work there, which is fine, they're not overly difficult. And that was worth 3 marks. Oh my gosh. I feel like there's a lot of marks allocated to quite simple questions. All right, moving on to question 6. Newton's method is used to estimate the x-intercept of the function, blah, blah, blah. I've seen these a lot with cubic, so I'm not going to say it's going to be a cubic on the exam, but I've seen a lot of cubics. All right, so verify that f of -1 is greater than 0 and f of -2 is less than 0. So basically just substituting in f of -1, x equals -1 and x equals -2. So it's just a basic show that question. So you're just working through. So 1 mark, bit of work there for 1 mark, but an easy mark. Using an initial estimate of x0 equals -1, find the value of x1. So you're just using Newton's method of approximation, which is on your formula sheet. You will be given an initial estimate, I would say. If you were not to give an initial estimate, then I don't know, they couldn't mark it, basically, because you could have 10,000 students giving you a different initial estimate. You may be given your final value and have to work backwards to find out what x0 is. I think that would be a great question to have. Possibly more an exam 2 type question, but can definitely have it here maybe. But I think because it's the first time it's being seen on the exam, you're probably going to have quite a simple one. But again, I haven't seen the exam, so I can't go making assumptions. But Newton's method of approximation is very straightforward. You've got your next value, so in this case x1, so you can see I've written there, is equal to, actually, I don't think I wrote that correctly. What am I doing? No, I just want n. Sorry, I'm writing a recurrence relation. Too used to doing general maths. Okay, xn, so n minus f of n over the derivative, and you can see I've calculated the derivative here. All right. Oh, no, I did do that correctly, sorry. That should be plus 1. There we go. Yes. So x1, and then we're substituting x of 0. Sorry, there's too many ones. All right, and question 7. So we've got okay, cool. A probability question. So we've got a piecewise function. So a piecewise function just means you've got multiple functions here. So multiple equations. The duration of telemarketing calls to mobile phone users is a continuous random variable. So as soon as you see a continuous random variable, remember it has to equal 1. So that's always a hint. We have to find the value of k such that 90% of telemarketing calls last less than k minutes. So, sorry, I thought my phone was ringing then. So your lower limit is 0, and then we've got this upper limit. We don't know what it is, so that's what we're basically solving. I just realized we don't need to use the fact that it's equal to 1 because it just wants 90%. So we don't want the 100% of it. We only want 90%. So that's why it's equal to 0.9. Then it's just a definite integral. So understanding how to find the antiderivative of exponential functions, and that's on your formula sheet as well. So make sure you're using your formula sheet, or if you're quite confident, even maybe just checking on your formula sheet. Now it did ask for this form, all right, and the reason why they might ask for a certain format is to make it easier to mark. I know we shouldn't be doing things just to make things easier to mark, but because there could be many different ways of writing it, or they could just be testing your understanding of the log rules. Okay, so getting to this point here, I thought, oh yeah, I'm done, and then I had to check. So if I go back up here, it does say that they're all positive integers. So basically this -5 on 2 is the same as -1 times 5 on 2. So that -1 can come up the power here, become the power there. And so 1 over 10 to the power of -1 basically is just 10. Just trying to think, if you had to do that on your exam and you didn't know it was 10, remember anything to the power of a negative just flips. So that 1 over 10 becomes 10 over 1. And there you go. So there's your value of k, and that's the end of the exam. All right, bye.